Hi students, welcome back to our class. How are you all? I hope you all are fine. Now I am going to teach you subject physics lesson number 4, simple machines. And now I will teach you the topic mechanical advantage. So firstly, I will define you what is the meaning of mechanical advantage. The factor by which machine multiplies the force applied, that is effort, is called mechanical advantage of machine. And in the other words, we can say that mechanical advantage is the ratio load to effort. And students, if load value is greater than effort, so in that condition mechanical advantage is always greater than 1. And if load value is equal to the effort, then we can say mechanical advantage value is equals to 1. And students, load value is less than the effort value, then we can say that mechanical advantage is less than 1. So students, we can say that if load value is greater than effort value, then the mechanical advantage of a machine is greater than 1, and then we can say that the machine is force multiplier. Now students, I will teach you the topic principle of a lever. But firstly, we will see what is the meaning of lever. We can say that lever is a simple machine which is commonly used in our daily life, and in simplest form we can say that lever is a simple rod A to B which can turn about the fixed point F, which is called the fulcrum. So students, now we will discuss about the principle of a lever. So in figure we can observe that a rod A to B which can turn about the fixed point F. So we can say that rod A to B behave as a lever machine, and it turns about the fixed point F. This is called fulcrum of lever machine. And effort E is applied at one point A on the lever, and load is exerts on the other point B, and the distance FA from fulcrum to effort is called effort arm. And the students, the distance FB, distance from fulcrum to load, that distance is called load arm. And students, when the lever is in balanced position or horizontal, so we found that load multiply load arm equals to effort into effort arm, and we know that this load upon this effort, that is in equal in multiply with effort arm, when it comes LHS side, so it is in divide effort arm and this LHS side load arm, when we go on the RHS side, so load arm will go in divide because it is multiply with load, so it go in divide, so it is equals to effort arm divide load arm. And students, we know that load divided by effort or the ratio load to effort, and it is called mechanical advantage. Mechanical advantage. So we can say that mechanical advantage is equals to load divided by effort, or that is also equals to effort arm divided by load arm. So students, we can say that mechanical advantage, that is the ratio of load divided by effort, and that is equals to effort arm divided by load arm. So we can say that mechanical advantage, it is the ratio of effort arm to the load arm, and it is called the principle of a lever. And students, we can say that if effort arm is greater than load arm, so mechanical advantage is greater than 1, and effort arm is just equal to load arm, so we can say mechanical advantage value is equals to 1, and effort arm is less than load arm, so in that condition we can say mechanical advantage value is less than 1. Now students, we will talk about the classes or orders of lever machine. So students, lever machines are divided in 3 classes depending upon the position of fulcrum, load and efforts, and they are class first lever, class second lever and class third lever. So now students, we will talk about the first lever of class first. So we can define that the lever in which fulcrum is lying between the effort and load is called lever of class first. Generally, in lever of class first, effort arm is greater than load arm. So in that condition, we can say that mechanical advantage is greater than 1. But if effort arm is equal to load arm, then we can say that mechanical advantage value is equal to 1. And if effort arm is less than load arm, so in that condition mechanical advantage value is less than 1. Now the examples of lever of class first are seesaw, pair of scissors, a pair of pliers, beam balance, a crowbar and a claw hammer. These are the examples of lever of class first. In these examples, fulcrum is lying between the effort and load. But you can see pliers in which effort arms are greater than load arm, so we can say that its mechanical advantage value is greater than 1. But in pair of scissors, here the effort arm is less than the load arm, so in that condition mechanical advantage value is less than 1. Now students, we will talk about the lever of class second. So we can define that the lever in which load is lying between fulcrum and effort is called lever of class second. In this figure, you will observe that lever of class second, the load is closer to fulcrum and effort is with distance from fulcrum. So here load arm, this distance from fulcrum to load, and effort arm, distance from fixed point fulcrum to effort, that effort arm, this effort arm is greater than load arm. So we can say that students, when effort arm is greater than load arm, so we can say that mechanical advantage of lever of class second is always greater than 1. The examples of lever of class second are nutcracker, wheelbarrow, mango cutter, paper cutter, and bottle opener. So in these examples, you will see that the load is lying between fulcrum and effort. So these are the examples of lever of class second. Now students, we will talk about the lever of class third. So we will define the lever in which effort is between fulcrum and load is called lever of class third. So in this figure, you will observe that the distance from fulcrum to effort, that is called effort arm, and the distance from fulcrum to load is called load arm. So in this figure, you will observe that effort arm value is less than load arm, or in another way we can say that the effort arm distance is less than load arm distance, so its mechanical advantage value is always less than 1. The examples of lever of class third are a pair of tongues, forearm holding load, sugar tongues, forceps, knife, spade. These are the examples of lever of class third. So in these examples, effort is lying between fulcrum and load, and effort arm, this distance is less than load arm distance. So therefore mechanical advantage is less than 1. So students, I hope you understood the concept of mechanical advantage, lever machine, principle of lever, and the three classes or orders of lever machine: lever of class first, lever of class second, and lever of class third. Thank you.